in the previous lesson regarding polynomials, I specified more on x squared and x cubed, and really those cubic and quadratic functions. But really those properties apply even for other functions that may have different degrees, but we're really classifying those properties in terms of whether the degree is even or odd. So looking at this again, we have a polynomial function that has an odd degree, right? It's x to the power of 5, and we have a negative here. And similarly here we have x squared, right, which is again really just an even degree, and we have a negative value before it. So we want to find the end behavior of these two functions, and if you get confused or anything, always just try to recall those quadratic and cubic functions and recall their end behaviors to really determine the end behaviors of these functions, because you may be given something like x to the power of 19. Just know that x to the power of 19 has an odd degree. So looking at this, what I would do is I would take a pic, or I would try to recall the graph of x to the power of 3, or x cubed, and we know that the graph of x cubed is something like that, right? That's just a sketch. Now we know there's a negative value here, so I would know in my mind that okay, it would look something like that now, right? And you can visualize this. And so now when we think about the end behavior, we really don't care what this is, as long as this is an odd degree, we're fine. So really, looking at this graph, we know that the end behavior here would be, so we're going to say rising, left, and we're going to say falling, right. So this is our end behavior here, and really we don't really care about the 5x, the 7.5. We look at the degree. Again, the degree is the greatest, it's the greatest power in that polynomial here. So again, that being 5 indicates it's odd, and we know there's a negative sign here, therefore it's rising left and falling right. Really something like this. Although this doesn't look like the graph of x to the power of 5, again, that visual representation of negative x to the cube can help us. Now let's go on to the second problem here. Again, this is just x squared, but we have a negative coefficient here. So if we think about it again, x squared is something that looks like this. However, we have a negative, so whatever this looks like, the end behavior is something, and it's going to be upside down. So really, our end behavior will be falling left, and then falling right. And if you think about it, really anything that has an even degree, it's either going to be rising left, rising right, or falling left, falling right. Whereas for a polynomial function that has an odd degree, you will see that it's going to be one and then it's going to be the other. When I say that, I mean you're going to see either rising left, falling right, or falling left and rising right. So it's going to be reversed in that situation. So that's just end behavior, and I hope I've given you an easy explanation as to how it works. So now we have something else, and this is more towards graphing, really, if you understand everything. But before I go into actually graphing different polynomial functions, it's important to understand exactly how multiplicity plays. So here, the first one, the first rule I would say is that if there's a multiplicity, if there's an odd multiplicity, right? If there's an odd multiplicity, then your function will cross at that point. And if there is an even multiplicity, then it's gonna bounce at that point, or bounce off that point, really. So those are the two rules. You may want to write them down, really, because those definitely help you when you graph polynomial functions. So the first one here, right, I have function f of x that is equal to negative x cubed minus 5x squared. And we want to graph this. Now obviously you know different things about end behavior. You know these two rules here, to apply. And then you also know that you can find the zeros of this by, again, factoring this and setting this to, equal to 0, really, like you would do for any quadratic function. So let's do that first. So we set this to 0, right? So we can determine the x-intercepts. Again, the x-intercepts are values of x for which y is 0. So we factor this out, right? As we factor this out, we see it's negative x squared, right? Times x. So yeah, we have negative x squared times x, and then we have plus 5, right? Because this gives us negative x cubed minus 5x squared. And really, this is what we have. Now, we want to set each factor to 0. So negative x squared is equal to 0. And x plus 5 is also equal to 0. So really, we see that x is equal to negative 5 here, right? And we see that x is equal to 0 here. Right, so we have 0 and negative 5 as our two zeros. So if we graph this now, we want to keep in mind that this was our function, right? And this is a function that has a degree that is odd, and obviously there's a negative 1. So again, if you just visualize this, it's going to be something like that's going like this, right? If we have a graph here, it's going to be something like goes like that. So we know that its end behavior, right? Its end behavior is rising left and falling right. That's its end behavior. So we know that. So we can do something like that. We don't know what's going to happen here, but we know it's going to go down. So it's going to look something like that. Now we know it's zeros as well. We know that it has a 0 at x is equal to negative 5, right? So x is equal to negative 5. Say that's negative 5. That's one of its 0, and the other 0 is that x is equal to 0, right? So that will be something like here. Now the question is it crossing or bouncing? And that's why these first two rules are crucial here. So if it's an odd multiplicity, right, it's gonna cross, right? And so you see that negative 5 is really just being repeated once, right? We don't have, it can be repeated twice, because this is what we solved. X plus 5 is equal to 0, so x is equal to negative 5. Now that has a multiplicity of 1, therefore it must cross. So it's crossing. However, x squared is equal to 0 again, because of the idea that this is degree 2, indicates that this may possibly have two different solutions. Really, even if you see x is equal to 0 as being the only solution, this solution is being repeated twice. And that would make sense, because if this solution is repeated twice and this solution is repeated once, that means that there are three different solutions, and which satisfies the definition of the polynomial, because this has a degree of 3. Usually with any polynomial, the degree value must match the number of total solutions. So 3 solutions and power of 3 here, or degree 3 here. So now we look at 0. It definitely has a multiplicity of 2, and therefore, because 2 is even, right? It's even. It must bounce off that point. So it's bouncing off and going like this. So this is how our function looks like. So again, using the ideas of end behavior, zeros, factoring, and knowing that all odd multiplicity refers to crossing and even multiplicity refers to bouncing, you can successfully graph various polynomial functions. So thanks for watching.